Hello out there in the interwebs. In these videos, I want to tear down products and see what we can learn about how they were designed and made. They are definitely not repair videos. I have no intention of ever putting this back together, so if that's what you're looking to do, you might be able to see how to get it open, but I'm not going to worry about keeping stuff intact and getting it back together. So, first product is the Xbox One controller. This is the version 2 because it's got the headphone jack. This one, as you can see, has been abused and a tad bit destroyed by my kids. I don't know if that's any fault of Xbox or Microsoft. I know they beat the crap out of these things. So let's get into it. So first, from the outside, as far as design, they obviously spent a lot of time and pretty much nailed the ergonomics. Everything is pretty much where you would expect it to be. The high buttons up here are a little awkward. Like the triggers are perfect. These ones, I have to kind of get a little awkward, but obviously it's not a huge deal. It fits really well in the hand. Dpad and joysticks are right where you would expect them to be. Everything has a good clicky feel. Another thing to notice on here is that there's no exposed screws, which is kind of commonplace these days, but is actually kind of a pain in the ass to get done in designing a product. So good job on that. I think what we're going to have to do is take off this panel here, and there's probably a screw somewhere in here. Yeah, right in there. Is it going to be the smallest one I have? Oh yeah. Okay, now see how hard it's going to go. At least it looks like it snaps and it's not glued together, because that would suck. All right. Ugh. Usual crud. All right. Let's look at. Ooh, I gotta clean this off. Okay. In looking at how this part was made, I'm looking for things that indicate the direction that the two mold halves would have come apart, and the bosses really could have only been made if this part of the mold came straight out. But what we have is a bunch of hooks that were holding the parts together. It was holding this one to the rest. Trying to get a good view of them there for you. So there's a hook. So if this part of the mold had to be able to retract straight off, it wouldn't have been able to do that with these hooks. And if you look really closely, you can see this kind of square shape right in front of each of the hooks. I'm going to try to get some good reflection for you. There we go. So you can see this square. That is where they had a special slide in the tool that would be in place and help mold this part of the hook. And then once the part is molded and this part of this half of the mold wants to come away, this part slides back so that this half of the mold can come off. It's one of the drawbacks of trying to make a part that doesn't have any exposed screws is you're probably going to pay more for molds and things to get features like this. So they had 1, 2, 3, 4, 5, 6, maybe 7 of those. So that's a pretty complicated little mold for such a little just cosmetic part. They've got lots of little ridges here to keep things secure and keep the gaps down. That's good. These bosses are not for screws. They're basically so that when this goes together, those register into these holes and help transfer load and keep it from getting popped off. All right, let's get the other half off. All right. Let's see what else we can learn on the inside of this guy. So no hooks on this one, so no little internal slides. You can see our little date of manufacturer mark. This is PC ABS. The recycle symbol. These things are kind of cool. So when this part was made, this part of the mold, the two halves of the mold came apart like so. And for ejector pins, you can see here's a ejector pin mark right there, a little circle, but you can see it's got kind of a hatched or a honeycomb pattern on there, and that's because it's up on this incline of the part. And if you look at the part like this, that ejector is up here on the incline, and if that little grid was not there, then that pin could slide on the part and wouldn't push straight off. So they put a little texture on there to give it some grip when they push it straight off. So there's a bunch of those here, same on the other side. All right, into the guts. We got our little vibrating motors here. So you can see it's just a motor with an off-center weight. There's a big off-center weight and a small one, so they can kind of tune how much it vibrates. You can see there's little vibrating motors inside of each of the triggers as well. Alright, so these wires come around to the front and go to the triggers. Okay. So we've got our joysticks. Let's see what this guy looks like. Wow, it's actually pretty cool in there. Yeah, some work went into that design. Gonna have to dig into that a little more. Huh. So when these guys get pushed all the way to one side, they stay. There's like a little detent there. I don't think that normally happens in use, so there must be a little limited travel. It doesn't let it get that far normally. You can see the little white frames in there, one for each axis. Let me get my fingers out of there. You can see one axis there, one axis there. I guess that's, I don't know. I'm not an electrical guy, but little potentiometers maybe. Whatever it is, that was quite a little science project to get the feel right, durability, and get the electrical output that you want. That's cool. You can see the boards go like so, and the connectors on this board go to the connectors on this board. So those connectors are kind of part of the structure of what's holding everything together, along with this guy screwing down on these bosses that are up higher than this board. Gets everything at the right level. Okay, so around to the front on the D-pad, there's this stamped sheet metal bit. First I couldn't tell, I wasn't sure if it was electrical or not, but actually it's a pretty good idea. All it is, you can tell, is just a piece of stamped, really thin sheet metal, and it's just pushing on the D-pad at each quadrant, and it's just to keep the rattle out of it. You know, they could have easily sized everything and toleranced it all so that there wouldn't have been too much rattle, but we all know the difference between like electronics that feel good and sturdy and electronics that feel rattly, and this is a definite touch point, so they wanted to keep that nice and non-rattly. So nice low profile, cheap way to do that, so that is a good idea. Back to the back side. These screws take the tiniest Torx head that I've ever seen. I had to go to Harbor Freight and get a new set. But now I have these. Apparently, when you get this small, you don't need security heads anymore. I guess the little post in the middle would be microscopic anyway. That's it. Okay. Still on the post, so I'm just going to put out a bit. Alright, so you can see it goes underneath these little plastic edge here. It's because the USB-C is connected to the board and goes through the plastic there. So I'm going to have to do some wrangling. This is a separate piece. You can see it's held on these little pins here. Okay, so this is how the button here works. You can see there's this long tab that comes off back here. When this is in place, that actually weaves between these parts down here, and let's get all that out of there. When the PCB is in place, that little tab on the button goes through and hits this button right there, hidden down in there. It's kind of cool. Alright, let's just see what dumped all over the table. This is how controllers and things and buttons have been done for a long time and will be done for a long time. You basically have a flexible material, some silicone or something, with a little conductive dot bonded in the middle, and you can see on the trace here, so you've got one lead coming in this way, one lead coming in this way. This one is connected to these lines here, and this one is connected to the lines on this side. When the button is pressed and that conductive pad comes down, it crosses over those and joins them. So that's just how the computer knows that you've pressed the button. It just knows that you connected these two leads. So this is another way buttons are done. This is basically a little stamped sheet metal piece, stamped and formed kind of dome. It's kind of domed in the middle, and it rests on these four pads, and when you press on the D-pad, it clicks. You can kind of see, let me try to get the reflection right. And you're doing the same thing as the conductive pad, you're just connecting two circuits. It's another super cheap way. So these ones are even, they just placed, and then you can see this reflective, just sticky pad that they put down on top of it to hold them in place. Yeah, so you can see the little conductive domes are not even attached to the board, they're just stuck to this, and it still clicks. And so this one's even more obvious. Focus. So when that dome comes down, it just connects across the two black areas there, makes contact, and it knows that you hit the button. There you go. These are the big shaker motors. See, it just shakes, and because it's off center, gives you that rumble feeling. You can kind of see how the weights are attached. It looks like they're just kind of crimped around the shaft. Yeah, they actually they're close. They're probably stamped to a very close size, and then some kind of squeezing or pinching tool clamps them onto the shaft. Okay, so I was getting ready to dig into the button here, try to get into the little vibrating motor deal, and I realized that there's not a rotary sensor on the shaft, and the trigger needs to know, it gives you variable feedback or control in the games, and so I'm like, how does that work? Then I noticed this like heat shrinked on magnet here. It's not a super strong, it's not a neo magnet, it's just a regular old magnet. Like, okay. And then I noticed these little components here, little board mount components, and if you look, when the magnifier says 304 on there, and I look up 304 Hall effect sensor, and there you go. It's a little board mount Hall effect sensor. So what it's doing is measuring the magnetic flux being generated by that magnet as you get closer to it and further away from it. So that's pretty slick. That's why it's such a smooth feeling trigger, because there's no mechanical like things rubbing as it's sensing the angle. All you're doing is fighting that spring, and that gives you a nice constant feedback or increasing feedback, and you're just electronically sensing the position. So that's pretty sweet.